Welcome to this tutorial on cumulative sum with np.cumsum. In this video, you'll learn how to calculate running totals in NumPy arrays. Cumulative sums are essential for tracking totals over time and analyzing sequential data. Let's dive in and master this powerful function. A cumulative sum is a running total where each element becomes the sum of all previous elements including itself. For example, if we start with the array 1, 2, 3, 4, the cumulative sum produces 1, 3, 6, 10. Notice how 1 stays 1, then 1 plus 2 gives 3, then 1 plus 2 plus 3 gives 6, and finally 1 plus 2 plus 3 plus 4 gives 10. Each position holds the total of everything up to that point. The basic syntax for cumulative sum is straightforward. You call np.cumsum and pass in your array. The function returns a new array containing the cumulative sum of elements. The original array remains unchanged. This simple syntax makes it easy to calculate running totals with just one function call. Let's look at a practical example. We import NumPy as np, then create an array with values 1 through 5. When we call np.cumsum on this array and print the result, we get 1, 3, 6, 10, 15. Each element is the cumulative sum up to that position. This demonstrates how easily you can transform an array into its running totals. For multidimensional arrays, the axis parameter controls the direction of the cumulative sum. Axis equals 0 computes the cumulative sum down the rows, which means column-wise. Axis equals 1 computes across the columns, which means row-wise. Axis equals none flattens the array first, then computes the cumulative sum. When you omit the axis parameter, it behaves like axis equals none by default. Here's an example with a two-dimensional array using axis equals 0. We have a 2 by 3 array with rows 1, 2, 3, and 4, 5, 6. When we apply cumsum with axis 0, we get cumulative sums down each column. The first row stays 1, 2, 3. The second row becomes 5, 7, 9 because we add 4 to 1, 5 to 2, and 6 to 3. This is useful for tracking totals across different time periods or categories. Now let's use axis equals 1 on the same array. This time we compute cumulative sums across each row. The first row becomes 1, 3, 6 as we add across. 1, then 1 plus 2, then 1 plus 2 plus 3. The second row becomes 4, 9, 15, 4, then 4 plus 5, then 4 plus 5 plus 6. This is perfect for calculating running totals within each individual record or observation. Let's recap the key points. np.cumsum calculates running totals of array elements efficiently. Use the axis parameter to control direction in multidimensional arrays. The function returns a new array with the same shape as the input, or a flattened array if axis is none. Cumulative sums are incredibly useful for tracking cumulative metrics like total sales, running averages, or accumulated values over time. Now you're ready to use cumsum in your NumPy projects.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.